So good afternoon, Friday afternoon. Here I am trying to get a video together, like I said I'd do. Been a really busy week, so we've had a lot of stuff go on this week. We've had lots of bikes come in for assessment and then repair. I just sort of showed you some of the repairs on the previous video. Had some bikes come in this week from around the bay where the person got injured, unfortunately, and sort of only now in a position to get their bike sorted out, because I mean around the bay was quite some time ago, but it was an awful day. It was very windy. Other thing, I was at the Banyule and Whittlesea Tech School Summit this morning, just talking about some tech education and introducing, having more technical learnings at school, from primary school through high school, etc. These students, they're the future, and the ability to do things, I think, is really important for the world. So it's one thing to be able to design something on a screen, but you actually need to put it into a real world situation. So being able to actually make things with your hands, or operate machinery and things like that. So it's one thing to design stuff, and it's great. You need designers as well, but you need people who can actually make things as well. So that was really positive environment. There's a lot of interest in those sorts of things. So another big thing this week has been the incident, a really unfortunate incident where a bike rider died due to his fork failing. The coroner's report was released just this week on that. We had some findings, on there was a manufacturing flaw in the fork, which caused the failure, and so there's been a whole bunch of discussions on those inspection standards and what's the life of a bike and things like that, and it's been debated on, well, it depends on how it's used and all that sort of stuff, which is, there's a lot of things to consider there, that's for sure. One of the things, though, I don't quite agree with is, the comments that people are making that, a bike's not a plane, so you don't need to inspect it to those sort of levels, but it's actually so similar, using the same materials, same processes, so it's got very, very much similarities to aircraft, and the only, I suppose the thing is, if a plane crashes, a lot of people get killed in one go. But if you crash your bike and you get hurt, it still affects you and your family in a significant way, as this gentleman has and his family have had to suffer. So, but the similarity between aircraft and bicycles. The Wright brothers were bicycle engineers, and then they developed their planes using that technology. So there's always been this sort of crossover with the technologies, and I think at the moment you've got with the bikes, you've got the aerospace sort of technology in terms of the composites, without the inspection quality that the aerospace has, and so because particularly making with carbon composite is its process, so with a steel or an aluminium tube, a lot of that quality control gets done at the mill. So when you get the tube in your hand, it's already had all the metallurgy done, all these quality steps have already been done. So when you put it together, you only need to focus in on the welds or the lugs or whatever you're doing. But with composite, each individual part is made separately and is cured separately, and so you need to be aware of the quality control aspects of each step of the process. So an analogy I use is like baking a cake, and you can have the same ingredients, but the cake can taste different, and you need process control. So that's the big difference with composites to other materials. The process control is all done in-house, as opposed to a lot of it being done at a foundry or mill or etc. So and it's been documented over and over and over that having manufacturing flaws like porosity, voids, foreign object inclusions, these sorts of things, wrinkles, that they significantly drop the mechanical properties of the material. So from an engineering point of view, a design point of view, you design a product to take a certain load, expecting the material to behave in a certain way, and if that material is now 20% less strong, it may not be able to take those loads. So so those sorts of things need to be considered, and it needs to be the quality control steps need to be put into place, so you're getting the structural properties that the bike was designed for. So that's that's sort of been a big thing this week. So what I'll do, I'll run you through a couple of forks that I've cut up, and just sort of show you some of these indications that I find, and we'll take it from there. So here's some forks, and some of the features with them. Okay, so those forks sitting up against the wall there are, apart from that steel one, right hidden in the corner, they're all basically forks that have been rejected in the last little while. So we've had a lot more forks be rejected, and they've been destroyed and disposed of. And there's another box as well which I have of dead stuff. So the sort of things that we're finding is, we'll go over on the bench here. Here is a whole bunch of forks. So this first one here is a Specialized. It's got aluminium dropouts bonded into the carbon legs. You can actually see a void, an adhesive void right there. And we go through the rest of it, and there's some wrinkles here right in the steerer, and there was actually a recall on some of these forks where they were failing in the steerer at that point. So that's been a bit of a concern. So the Specialized did a repair on that, where they bonded a sleeve inside to increase the strength of that area. So that was like a factory repair. The next fork here is it's an Edge Composites, which was the company, which was Envy basically before they changed their name. They were Edge Composites. But this is one of their early forks. You can see some really significant wrinkling going on here. Down the legs, there was a bit of resin dry, and full carbon dropout. But the fiber's a little bit random in its orientation. We can't see it, but there's a void. Oh yeah, there we go. There's some voids right in the middle of it. As you can see, the fiber is just in random directions. So that's that one. Here we have a BMC, and it's got an internal rib, but look at the dropout, and you can see the fibre following the dropout lines there. So it's a separate piece and then bonded in. There's plenty of adhesive there, so no voids, which is it's always a good sign. But on this one, we found in the what's marked in yellow here, we found some voids in the steerer, so you can see them there. Again, very similar spot to the that previous Specialized fork. The next one is an Apollo. I only just cut out this section in the steerer where, again, exactly the same sort of spot, about halfway down the steerer. Again, a nice big planar void that was found with the ultrasound scan. And finally, we have a giant fork, and it's got a couple of things. So again, in the middle of the steerer, that indication up here, and then also a bit lower down. So you can see the void there, and also a bit of void there. And the concerning thing is that in all these forks, the voids are in the steerer in about the same spot. So it's a process. It's a processing. It's how the pressure and the compaction comes on during the curing of the material. So obviously a concern. The other thing I'll just briefly touch on is the compression plug on the fork as well. So I'll just show you this little video of one of the compression plugs which which came through during the week, and it's a really lightweight design, but it's not ideal in that it doesn't actually do what it's meant to do. So remember that the compression plug is important to take that hoop stress load for when the stem clamps on the steerer tube. So it is structurally significant. So don't try and skimp on that and think that it's just there to load the headset. It's actually much more structural than that. So I'll show you this video, and it'll give you an idea on some of the things to look for. Here we have a compression bung, and this is a really lightweight one. The only problem with it is it doesn't really do the job that it's meant to do. So when you put it into the steerer, it can move around. So what that means is these little sort of radial loops, which are designed to then contain the hoop stress, the steerer needs to compress until it hits that before they actually do before they actually contain that hoop stress. So that's a bit of a problem. We see a lot of forks where when the stem clamps it crushes the steerer. That's called hoop stress. Okay, so that's it for another week. I'll see how I go next week. Try and get another video out, or a couple of videos. We'll try and find some time to get some camera gear and all that sort of stuff, but we'll get there. I'm going to the US end of next week, on that next weekend, so I'll see how I go getting videos while I'm away. May or may not be possible, but anyway, keep looking at the Instagram feed. Subscribe to the channel if you haven't already done so, and let's see where this channel takes us. So have a good weekend, safe riding if you get out, and thanks for watching. Okay, all the best. Bye.